All right, sixth grade, welcome to today's lecture. Uh, Last time we left off, we were talking about how saltwater is more dense, right? And the primary reason that saltwater is more dense than freshwater is because of its high salt content. Adding those molecules of salt in there really adds to the density of the water because there's more matter in a certain area of a certain volume of matter. And so because of that, saltwater is very dense. We can take advantage of that density using a technology called sonar. Animals also take advantage of something similar to this, where they bounce sounds off of other things to locate where they are. So, for example, certain ocean animals like whales can take advantage of sonar sound to communicate with other members of their pod and to see how far away those members might be. Other animals are going to use it to navigate as a way of seeing how far away they are from the ocean floor or from certain landforms that are in front of them or just things like that. We use sonar. So sonar is our name for this technology called sound navigation and ranging. So sonar is an abbreviation. It's an acronym. It stands for, we take the first two letters of sound, the N from navigation and the R from ranging to get sonar. And so sonar is going to be used to see things sort of beneath the ocean surface. And so I want to show you guys a picture of what this would actually look like. And so we would take a ship and we would put it over, have it go back and forth and kind of, so we would have it do passes back and forth, back and forth, back and forth over the ocean. And we would point a little device here that would be kind of pointed this little, oh, sorry, I meant to draw. We would have this little device pointed downward, okay? And it would point down into the ocean and it would be sending out these pings of sound. Now the sound would travel down, bounce off the ocean floor, and then come back to a computer, which would see the sound or interpret that sound and then contribute to a map. So we could get a map of the ocean floor, and we'll talk more extensively about ocean floor mapping a little bit later. But just to give you an overview right now, if this sound took a short amount of time to come down and bounce off, the computer would interpret that as a higher part of the floor. If this sound took a much longer time, so for example, this purple area here, if it took longer to travel all the way down and then bounce back up to the ship, that would be interpreted as something that was lower, as a deeper part of the ocean, and so that would be marked with kind of this purple color. So we can actually get a three-dimensional map of what the ocean floor looks like in figuring this out. For submarines, when they travel underwater, it's obviously difficult to see if you're doing something like navigating a large submarine. There's no windshield, right? So they also have to use some sonar to travel around and through obstacles in the ocean. All right, so let's talk a little bit about waves. The primary factor with waves that causes waves is wind, okay? And the reason wind causes waves is because it creates friction between the wind or the moving air and the water. And so a couple of things can cause larger waves. And if you think about this for a second, you could probably figure it out on your own. If you're at the beach, think about what sort of day would cause bigger waves. Probably a stormy, windy day, right? And so the harder the wind is blowing and the longer it blows, the higher waves are going to get. There's also one more factor that's really important, and that is fetch. So think about a place where you might go surfing, okay? Where would you go if you wanted to get some really big waves? Well, there are two places you might say, since we're in the United States, you would probably think of two places that we have here. The first of those is California, right? And if we think about where California is sort of geographically speaking, this is my very simple drawing of California. Over here we have what? Well, hopefully you said the ocean, right? So over here we have the Pacific Ocean. And the Pacific Ocean is really quite large. And so as wind blows across the Pacific Ocean, it can blow for a long ways. So the wind can blow all the way across the Pacific Ocean before it starts to hit California. This distance that wind can blow over, so the distance of open ocean that a wind can blow over, is called fetch. And the larger the fetch, the larger the waves. That's why you get competition, you know, like 25-foot waves, okay, in places by the Pacific Ocean. So for example, Hawaii would also have really large waves. There are places in Australia where there can also be really large waves. What those things all have in common is that there's a lot of ocean leading up to wherever that location is that the wind can blow over. And because the fetch is really long, it can have really large waves. This is why if you have a house that's by a lake, right, or if you go to a lake or something like that, you don't really ever have to be worried, at least in Colorado, about giant waves overtaking your boat. Most of our lakes in Colorado are fairly small, right? You have a fairly small pond or a lake. The fetch is going to be extremely limited. Let's say the wind blows across this direction. The fetch is going to be extremely limited. Even if the wind were blowing across the other direction, you might be able to get maybe a couple inches worth of wave, maybe even a foot wave on a really stormy day, but you're not going to get a very large wave. Now, if you were to take your boat somewhere like the Great Lakes, okay, up by Michigan, there are certain lakes where you may actually be able to get very significant waves to your boat because the fetch would be larger. So fetch is also going to be one of the primary determining factors of the size of waves. Just something to keep in mind, the primary factor when it comes to waves is wind. And that wind can affect it in three ways. Basically, how fast the wind is blowing, how long the wind has been blowing, and the amount of space or the fetch that the wind can blow over. A couple of terms when it comes to waves that I would like you to be familiar with and be able to recognize. The crest is the scientific name for the tallest part of a wave. The trough is the scientific name for the lowest part of a wave. And then wave height is the distance between a crest and a trough. So it's a vertical measure. And then wavelength is the measurement from one crest of one wave to the crest of another wave. So that would be your wavelength. Crest, trough, and wavelength are the three wave terms that I would like for you to be familiar with. Now I want to talk about one more thing, and that is, look at this little seagull, right? So let's imagine how water and waves interact. So this little seagull, you'll notice, as he sits on this wave, and if you've ever gone to the ocean, you may have done this yourself. If you swim out past where the waves are breaking on shore, now it's important to emphasize that you have to be past where the waves are actually breaking. Let's actually take a second and talk about waves breaking so I can explain that to you. If you have a shore here, as water travels up the shore, it will sort of stack up and eventually a wave will actually have to break over itself. At this point, the water is actually falling over the wave and down. So if you wanted to go surfing or boogie boarding or play with a skimboard, some kind of thing that you do with the wave, you want to do it right here in the zone near the shore where the wave is breaking. Because when the wave falls over and is pulled down by gravity, it actually will move you forward. And that's where the fun part of waves come in. But if you were to swim up and over this wave or through this wave, and you were going to travel further out to sea, so you were over here, you could experience the same phenomenon that the seagull is experiencing here, in that the seagull is able to sit on the wave, and the wave moves through the water, but it doesn't actually move the water. And so the seagull just goes up and down, up and down, up and down. He does not go forward, okay? So what I'm just trying to illustrate here is that when waves are out at sea, the wave moves through the water. It does not actually push all of the water in front of it. This is just an example of out at sea, how big waves can look. Now, this is not an actual, this was filmed as part of a movie, but waves like this are actually can be generated out in the ocean. It's just easier to see better pictures of them here. And so when waves encounter an object, they will also do that same thing where they break over it. The waves run into it, and then the wave is pushed over and kind of pulled in by gravity. And that's what you can see here. All right, so we're going to talk, shift for another time and talk about tides. So tides are not like waves. They aren't affected by the weather or by wind or by anything like that. Tides are consistent and predictable. So we can write rules for tides. We can tell you what the tides are going to be on a specific day, and they're expected, okay? And the reason is tides are governed by gravity. And that's because the Earth is here in space. So here we have our planet, and then around that we have sort of I want you to have an imaginary bulge of water, okay? And sometimes the bulge of water is more evenly distributed, and sometimes the bulge of water is more unevenly distributed. We're going to talk about what causes that, but it's basically the sun and the moon. So the sun and the moon can either be pulling in opposite directions of each other, or they can be pulling in similar directions. And so that's going to change the shape of that bulge of water. And that bulge of water is what's going to determine our tides. Now we have two tides that we're going to talk about. We're going to talk about a flood tide and an ebb tide. So you may have been to the beach before and you have experienced what we call high or low tide. Flood tide, ebb tide are the same terminology as high tide, low tide. So a flood tide would be this picture here on the left. The water has come into shore. There's enough water to float the boat here. That would be a high tide. Low tide, you can see that the water has gone quite a ways out. So if you look out here, we have very little water close to shore, right? You can see a little down here, but you can see that the water's gone all the way out here. And obviously this boat's resting on the floor. So the differences between tides is not always this extreme though. Okay, this is a pretty extreme difference between high tide and low tide. But the difference between high tide and low tide can vary throughout the year. And that's what we're going to talk about now. So the greatest ocean bulge forms when the sun, the moon, and the earth are all aligned. This alignment is going to happen twice a month. And that would actually look like this. So I'll go back to that slide for just a minute, but I wanted to show you the picture first. So the sun is farther away from Earth, but it would be over here. Then the Earth is in line, and then the moon. So what happens is the moon is pulling on this bulge of water, and it's pulling this way. And the sun is pulling on this bulge of water, and it's pulling it this way. So what we get is a very elongated shape here, okay? It's very oval and less circle, okay? So what that means is when the Earth is rotating and you're in this portion, you have an extremely low tide. And when the Earth is rotating and you pass through this position, you have an extremely high tide. So during spring tide, we get a large variance between our low tide water level and our high tide water level. So the high tide is very high, the low tide is very low, and the difference between them is quite noticeable. All right, I'll go back to the notes now. So that is called a spring tide. So our sun, earth, and moon are all aligned. Because they're aligned, that bulge turns into a very long oval. And what that does is it makes the high tide high, the low tide low, and we get what we call spring tide. Now, the alternative to this is to have what we call neap tide. Neap tide is where the moon and the sun are pulling at right angles to each other. And so the difference between high tide and low tide is going to be very small. So if we look here, the sun would be here, the moon is here. So the sun is pulling this way. Whoops, sorry. So the sun is pulling this way, the moon is pulling this way, and we get a much more spherical bulge, okay? So still when you rotate through, when the earth rotates, this would be our low tide, and this would be our high tide. But there's going to be less difference between them. So our water level is going to be closer. Our low tide will be a little less low, and our high tide will be a little less high. And so we're going to get a more gradual change between high tide and low tide. We are in a season of neap, or we are at the neap tide when the difference between these two is at its lowest. All right, so twice a month, we're gonna go through our spring tide. Twice a month, we'll go through our neap tide. And so that's just going to change the variation. When we're in our spring tide, we'll see a big variation between high tide and low tide, the biggest possible variation. When we're in neap tide, we see the smallest possible variation between high tide and low tide. And then as we pass from one spring tide to one neap tide, it gradually shifts toward the other. And then as we pass from neap tide back to spring tide, you'll see the tides gradually shifting towards that spring tide. And so we're going to cycle through each of those about twice per month. All right, the tides is the last thing that I wanted to cover in today's lecture. So next time, next week, we're gonna pick up and talk about ocean floor mapping and ocean organisms. I hope you guys have a great week and you enjoy the break that's coming towards the end of the week. Please let me know if you have any questions. Either hop on Zoom or send me an email. I would love to chat with you about them. Bye-bye.